Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have Gerkey, co-founder and CEO of Open Robotics, a company that creates open software and hardware platforms for robotics. So welcome, Brian. Super happy to have you here today.
Thanks for having me. It's great to be here.
Okay, so why don't we start the interview by allowing yourself to introduce to our audience, maybe share a little bit about your experience, what you have been doing, etc.
Sure, happy to. So as you just said, I'm with Open Robotics, and what we do is we make open source software for the robotics industry. Primarily, we're best known for two products. One is ROS, the robot operating system, and one is Gazebo, which is a robot simulator. And ROS is used to develop autonomy applications for robots. So if you're going to build a robot and you need a lot of software to build the application for that robot, you want it to do something, then ROS is the toolkit that you reach for to build that application. It has all the developer tools, it has the algorithms, it has all the device drivers and everything else that you need in order to build those applications. So if you think about like what runs on robots, it's ROS. And then Gazebo is a 3D physics-based simulation that you can use to do all the testing and development in software only when you don't have access to the hardware, or you want to do, for example, continuous integration testing of your algorithms. You can do it all in a realistic environment, just in software. And these two platforms together, there are other things that we work on, but those two platforms together are what we're best known for. And they're used now across kind of any kind of robot that you can imagine everywhere in the world.
Wow, really interesting. Okay, so I now have an idea of what Open Robotics does, but like, how did your interest in robotics begin? Like, I know that you went to school for computer science, so how was this change?
Yeah, so when I was in undergrad at Tulane University, I was in a computer engineering program, and there was a professor named Jim Jennings who had a lab in our department, and it had robots in it. And so there was a time when as an undergrad, I had an opportunity I was supposed to go like find a lab and, try to do something interesting in one of the labs with the grad students. And he had robots, and robots are really cool. So I just, I just gravitated naturally toward that environment. And there's something about, and you hear this from people who work in robots pretty frequently, that there's something about writing code and then having it have a physical effect in the world that is really different from most software development. Most software development, ultimately, you end up, getting the right answer on a screen, but that's just not the same as making something move around in the world that you can observe with your own eyes. And I just found that really satisfying. So from there, ended up going to grad school in a robotics lab and just been in robotics ever since.
And which year was this?
Now you're asking me how old I am. This was a long time ago. This was the mid 90s when I first started working in robotics. And then I know I see by the light, the wideness of your eyes that I know robots have been around for a long time. So I started grad school in the late 90s, and that was and that turned out to be a really important experience for a number of reasons. But if we think about like how that flowed into open robotics, one of the problems that we had at the time was a problem that a lot of labs had. So if you were in a robotics lab, you would get these robots, and your goal is to use those robots to do science. You're supposed to do research with them. They're basically, you can think about them as like experimental instruments. It's like, to an astronomer, you need a telescope; to a roboticist, you need a robot. And you just need the robot to work, and then you can do experiments on top of it. But often the robots didn't come with very good software. The software that came with them was usually proprietary, provided by the vendor, and it didn't do everything you wanted, and you couldn't change it. And so we, being, a bunch of confident computer scientists, said, well, we can write code. So we just wrote our own software to replace what the vendors provided us. And then, because we were kind of idealistic, we made it open source. And so we started a project it became called the Player Stage Project in the late 90s. And we put it up on the internet for everybody to, be able to work with. And that we started seeing, from around the world, other labs started picking that up and using it on their own robots and extending it and modifying it. And so that's where I really got the interest in developing this infrastructure for robots. And that's really like, if you think about what we do as a company, we don't really build we don't build robots ourselves. We don't even really build the autonomy applications themselves. What we do is, I think of us as like, we're filling a toolbox with tools so that everyone everywhere, from a classroom to a research lab to a product-based company, can take those tools and then use them to build the applications they want to build.
Wow, this is really interesting. Okay, and when you mention and you say we, how many people are you referring about? Like, how did you meet your co-founders? How did you, okay, you have the idea, you had experience, but like, why Open Robotics? Is there a reason behind the name? Is there a reason behind the company? How was that?
Sure. So I guess I have to explain a thing that happened in the middle. There was a company called Willow Garage. This was a robotics R&D company that existed in Silicon Valley from about 2008 to about 2013. And I ended up going to work there. And so I ended up running the software engineering team there. And we were doing a couple of different things, but one of the things that we were doing was really building this open source robot software platform that became ROS. And at the time, the goal was to provide this platform to work with the PR2. That was a particular research robot that we were building. It was a large kind of human-sized, two-armed mobile robot that we were giving out to research labs, and we wanted to provide software to go with it. That's where ROS came from. So we were building ROS. It was work that was all like a great experience, and we were starting to get a lot of traction. So we had labs and companies all around the world now starting to pick this up and contribute to it. So in 2012, there were a few of us at Willow Garage who decided, let's spin off from there and create our own company that has this particular focus. So rather than being a general R&D company like Willow Garage was, we said, look, this open software platform, that's important enough on its own. That's something that we feel passionate about. It's something that there's a large community out there that relies on all this software, and it really deserves to have a company that is dedicated to focusing on that. And so that's when we created Open Robotics. And that was, in fact, we just celebrated our 10-year anniversary this summer.
Well, congrats on that. I didn't know that. But I wanted to ask you, like, why would you say it was the biggest technical challenge while building ROS? Because, I mean, yes, you had experience, but I mean, no one can tell you about it, since it was kind of new for all the industry. What would you say was the hardest part?
I'd say the hardest part historically, and it's still the case for us, is managing the breadth of applications that we're trying to address. So if you think about what is a robot, that's just like it's an old philosophical question in the robotics industry that everybody laughs at because there's no clear answer. But it actually matters here, because if we say we're writing software for robots, that means we're writing software that needs to work for a robot arm in a factory. It needs to work for a mobile robot that's doing sidewalk delivery of packages. It needs to work for an autonomous car. It needs to work for a free-flying robot in the space station. NASA has robots in the space station that run ROS. It has to work for drones. It has to work for underwater vehicles. And so a really difficult technical challenge is, how do you balance how do you build a common platform that works well in all those situations, given the very different requirements that you have in all those situations? And so it's still something we struggle with. We struggle with it today, is how do we build something that's flexible enough to cover all those use cases, and yet not so insanely complex to use and configure that nobody can figure it out.
Okay. Wow, really interesting. I had no idea. And I also know that you got like recognized by the Silicon Valley Business Journal 40 under 40. And I was reading that and I was like, wow, this is really interesting. Like, you must be super proud of it. And actually reading the questions that they ask you, they mentioned like, what was your biggest success in the company, the biggest achievement? And it was really interesting to me that you mentioned that one of the things that you enjoyed the most was giving software away for free, like just like you mentioned. So at this point of your life, at this point of the company, I can see your eyes, Ryan. It's nothing bad, don't worry. What will you say? Will you say that has been the biggest achievement?
So that's a great question. I was trying to remember what I said in that interview. I didn't remember. So that was already several years ago. So that sounds like I said something reasonable. That's good. So I think that's still the underlying achievement, right? Because that's what we've always done, is we write all the software and we give it away for free, and then we see what happens with it. So then if I had to pick a particular thing that I'm really proud that we've worked on, I mean, I'll cheat and pick a few things, or just like looking back over the last few years. We've established a really close partnership with NASA to work on a rover that they're going to be sending to the moon in 2024. That's going to be using ROS as part of its control system, and they're using Gazebo extensively to simulate it. So that, I went to space camp when I was a kid, and that's the closest I'll get to space, is to have something that, we worked on go to the moon. So I'm really excited about that. In a like completely the other direction, we've been working for the last few years with a number of groups, including the Monterey Bay Aquarium Research Institute, on using our software to help make their underwater robots better. So this is a group that uses autonomous underwater vehicles to study the ocean. Their goal is just to learn about the ocean. So they've got these vehicles. They look kind of like torpedoes, but they're not weapons. They're sensor carrying payloads, and they're out there to go all over the ocean and just learn more about it, just to gather information. They're basically trying to increase the volume of humanity's knowledge about the ocean. And so having the opportunity to help them with a project like that, I think is just fantastic.
And now that leads me to the second question, like, what would you say it has been, I don't know, the project that you have enjoyed the most? Is it space? Is it ocean exploration? Is it what?
So I'd say the projects that I'll pick a series of projects that we've done. We've been working with some government agencies, US government agencies, like DARPA has been a big supporter of ours over the years. And DARPA is a really interesting agency because they pick a problem and then they go really, really hard at that problem for a few years. They have this model of like, let's pick something that's important that we should try to tackle, and let's kickstart the industry and push it in that direction. So a famous example of this is when they did the DARPA Grand Challenge, a series of those in the mid 2000s, and that basically led to the autonomous car industry. So when our company got our start 10 years ago, our very first project was with DARPA, and it was for what was called the DARPA Robotics Challenge. And this was motivated by the disaster at the Fukushima nuclear power plant after the tsunami hit Japan in 2011, I think that was. 2011. And the idea was, if only we had better robots to send into those disaster response kind of settings, then we could have helped. We could do more. We could try to fix these problems. And so this was a whole program that ran for several years that was built around the idea of let's just kickstart the state of robots that you can send into disaster settings to help people and help prevent property damage, basically. And our role as a company was to do all of the simulation of that. We simulated the whole environment. We simulated the robots. We ran a cloud-hosted competition in which teams from all around the world could submit their entries and see how they did. And that was a really exciting project for us that finished up in 2015. We've done a few others, but we also just finished another big project for like that for DARPA that was called the Subterranean Challenge. So here it was a different setting. This was imagine an underground environment, and you've got a search and rescue type task, like a collapsed mine or something like that, where you need to send in robots to try to find the people and, at least locate them, maybe bring them out. And so the setup for this challenge was, you've got underground caves, tunnels, other environments, and you want to send in a team of air and ground robots that are going to explore this environment and try to find all the people and other artifacts. And again, we built up all the simulation for that. And the really compelling thing about our role there in building up all this simulation infrastructure is that it levels the playing field for people to participate in these programs, because there aren't that many places in the world where they have the resources and the support at their own institution to build a team and get, say, a dozen robots and be able to take them somewhere and have them compete in a challenge like this. But anybody with a computer and internet connection can compete on the simulation side. And what often comes out, and this actually happened in the Sub-T challenge, is the winner will be a single individual. It'll be one person somewhere in the world. You've never heard of this person. You wouldn't have guessed that person would be the one to win this very high profile, prestigious robotics competition. But that's what's enabled by doing it all in software and then making it available to everybody.
Wow, that's great. And how long is this project going to last?
We just finished it, in fact, last year. So it
Uh,
ran for about 4 years. We just wrapped it up at the end of last year.
this all relates to the virtual reality somehow that we're living, right? And this happened with the pandemic. Like how hard it was. Did you find any critical challenges, especially since I know that you're working mostly with software, but maybe in the hardware part, did you have any challenges when it came to the procurement?
Yeah, because we focus on software, we actually, as an organization, I think we had it relatively easy during the pandemic. I would say that and in fact, it helped. There were two things that really helped our experience through the pandemic is that, for one, we've been focused on open source and leading an open source community for our entire existence. And so we're very used to, even outside of our own employees, our collaborators who work on projects with us are spread all over the world. And we collaborate with them asynchronously online all the time. And we do all our work in public online all the time. So when everybody had to go home, it wasn't that different, the kind of work style. And then even within our team, starting several years ago, we had already been adding folks to our team who were full-time remote. Because we're headquartered in the Bay Area in California. We have an office in Singapore as well, but not everybody is willing to relocate to one of those two places. There are great people out there who have great skills and they already live somewhere else. And so we had been, hiring people who were working full-time remote anyway. And so then, in fact, I remember the day that we all had to go home from our Bay Area office, some of our people were kind of freaking out, like, oh my God, what do we do? But their own colleagues on the team could just say, it's going to be okay, guys. You've been working with me for the last 5 years and I've been working from my house the whole time. It's going to be okay.
Okay, wow, that's great. And how many people did you start the company with, and how many people do you have now?
At the beginning, we had a total of, there were 6 co-founders in that first summer, a relatively large co-founding group, because there were 3 of us who left Willow Garage to start, but then we very quickly brought on 3 other key people. So there were 6 to start. And today we're 50.
Wow.
Yeah.
Wow. And it has been going on for 10 years.
It has.
Wow, that's great. It's super exciting. Okay. Thank you so much, Brian. Do you have any last advice for future entrepreneurs? I mean, especially since you have like tons of experience in the field.
I'll just say that pick something that you are truly passionate about. That's what I've done. That's what we've done with Open Robotics. Is we do it because we love it. And if you're going to do it for a long time, you have to love it. There can be other benefits to it, but it's got to be something that you really believe in.
Okay, straight to the point. Thank you, Ryan. That was amazing. And thank you so much for being here and sharing your experiences with us. Do you have any social media handles? Where can people find you? Where can people follow you?
I am such a Luddite. You're not going to find me on social media, but you'll find various handles for Open Robotics. So go check that out. I
tried to look for you. You are not anywhere. I mean,
my strategy is working.
Yeah, it is working. That's great. Well, thank you so much for being here, for sharing your experiences once again. Remember, guys, that you can also find more information, interesting articles, interesting interviews like this one directly on our website, controlhub.com/builder-nation. We would love to hear from you. And once again, thank you so much, Ryan. This was amazing. This was really interesting. And congratulations on the 10 years.
Thanks for having me.